Alright Titans, it's Mr. Spilker here, and I'm going to take you through Chapter 5, Section 6, our last section of Chapter 5. And this section is titled Parallel and Perpendicular Lines. So go ahead and make your heading 5.6, Parallel and Perpendicular Lines. Let's jump into this with a little discovery. Here we're asked to graph the following two equations on the same coordinate plane. So I'm going to go ahead and graph equation number 1. Equation number 1 has a y-intercept of positive 4 and a slope of negative 3/4. So I'm going to go down 3, right 4. Draw my line. Now I need to graph my second equation, and my second equation is in standard form, so I will change that into slope-intercept form. I'll move 3x over. When it changes sides, it changes signs. And then I will divide by 4. And that leaves me with y equals a negative 3/4 x plus 2. Now when I graph my second line, my y-intercept's 2. I go down 3, right 4, and I draw my line. And what do I notice about these two lines? Yep, you guessed it, they are parallel. The definition of parallel lines are two lines that do not intersect. And what do you notice about these two equations? What do these two equations have in common? If you look at the first equation, the one we did here, and the equation down here, what do the two equations have in common? You're correct. They both have the same slope. This right here, ladies and gentlemen, is very important to get down into your notes. Parallel lines have the same slope and different y-intercepts. Parallel lines, same slope, different y-intercepts. So for example, these two lines right here are parallel. And the reason that these two lines are parallel is because they have the exact same slope. They have the same m. Make sure this is in your notes. Parallel lines have the same slope and different y-intercepts. Here's an example of a question that may come up on a test or on a homework assignment from this section. And this example says, write an equation in slope-intercept form of a line that is parallel to y equals 3x minus 7, and it needs to have a y-intercept of 4. Well, if a line is parallel, that means it's going to have the same slope. So the slope of this line is 3. So the slope of my equation must also be 3. And then the directions say it must have a y-intercept of 4, so I'll go ahead and put a plus 4 on the end so that my equation has a y-intercept of 4. This is an example of a problem that you might see on a quiz or test from this section. Alright, the second half of our lesson is perpendicular lines. With perpendicular lines, we'll go ahead and just jump right into this. Perpendicular lines are two lines that intersect at a 90-degree angle. So that might be an important definition there for you. Perpendicular lines are two lines that intersect at a 90-degree angle. And the key with the perpendicular lines here that you want to have written down is that the slopes of the perpendicular lines are opposite reciprocals. Perpendicular lines have slopes that are opposite reciprocals. Now that might be new to you, so let's go ahead and talk about this. First of all, opposites, I don't think that part of it's new to you. I think we all know that the opposite of 3 is negative 3. The opposite of 5 is negative 5. The opposite of 8 is negative 8. The opposite of negative 12 is positive 12. I think we understand opposites. But what may be new to you is the word reciprocal. Reciprocal basically means take the number and flip it. So the reciprocal of 2 would be 1/2. The reciprocal of 3/4 would be 4/3. The reciprocal of negative 5 would be a negative 1/5. All right, those are what we call reciprocals. You take the number and you flip it. Now, in this case with perpendicular lines, understand that we're dealing with opposite reciprocals. So with opposite reciprocals, not only do we have to flip the number, we have to change the sign. So the opposite reciprocal of 2 would be negative 1/2. Because we change its sign, we flip it. The opposite reciprocal of negative 4 would be a positive 1/4 because we change the sign and we flip it. So that's a key vocabulary term, and that's opposite reciprocal. When you see opposite reciprocal, just think, change the sign and flip it. So the example that we have here, once again, I would put this one down into your notes right there, and that is that y equals 1/2 x minus 10 is perpendicular to y equals negative 2x plus 4. You can have the same y-intercept. With perpendicular lines, the y-intercept is not a big deal. It can be the same. But the slopes must be opposite reciprocals. Now, the example that I have down here is an important counter example. Y equals 1/2 x minus 10 is not perpendicular to y equals 2x minus 10. And why are these two on this last example not perpendicular? Because the slopes are not opposites. So make sure with perpendicular lines you have down in your notes that the slopes are opposite reciprocals. And opposite reciprocal means change the sign and flip it. All right, to finish up our teaching lesson here, they want us to write an equation in slope-intercept form for a line that has a y-intercept of 4 and that is perpendicular to the line y equals 3x minus 2. Well, if it's perpendicular, I have to take the slope, which is currently 3, and change it to its opposite, so it's going to become negative, and then flip it. And if you take 3 and flip it, you get 1/3. So y equals negative 1/3 x, and then they said have a y-intercept of 4, so I put a 4 on the end. All right, Titans, hopefully that helps you understand Chapter 5, Section 6, Parallel and Perpendicular Lines. Come to class ready tomorrow to practice this. Come to class tomorrow with any questions you have over this, and also begin preparing for your Chapter 5 test, which will take place on Monday and Tuesday of next week. Thanks for listening tonight, Titans. Stay classy.